All right, let's look at segment AB. What is that called?
AB. Yes.
It's a chord. What about GH?
Radius.
Radius. And then I have line CD.
Secant.
Secant. What about line FE?
Tangent.
Tangent. And then we have segment KH? Diameter. And we know this one has to be diameter because it's going through the what? The middle or the center. Perfect. And then we have the arc ED. What would that be? Minor arc. Okay, let's move on over to the next one. Now it's saying find the measure of the arc AB. Where's AB? Is that B right here? Yep. So we know central angle is what of the arc?
Same.
It is the same, so it's got to be 48 degrees. Oops. And then can I go the other way around for angle X?
Yes.
We have the arc and the central angle should also be the same. Then let's move on to the next one. So if the center is equidistant to the chord, then we have a lot of facts here. All of these are going to be split in congruent pieces. So let's fill in what I know. We know CG is 4. Then we know GD should also be 4, and that's consistent to the other two. So what must be AB? 8. What about EG? So EG is, where's my E? Oh, E is the center.
Where's
F is right here. So for the EG, could we make a right triangle? Oh, goodness. But do I even need that one though? Oh, they gave us EF, huh? So we know EG should also be 5. But I guess if I did ask for ED, could we use Pythagorean theorem? Yes, we can. All right, let's move on to the next one. What is my point of tangency here? Angle what? Angle B. So let's put in what I know. It says angle ACB. So ACB is 40. So it looks like I need to connect the hypotenuse. That's 40. Then I know my central angle has to be what? 50. And then it's asking us, well, what is CAB, the arc? I guess it's not the arc. The central angle alone is already what? 50. But if I wanted this arc right here, is it also congruent to 50?
Yes.
Yes, it is. Okay, next one. So we know AB is 24. Then what can I say about these two individual pieces? 12. Good. And then I have the radius is 13. So let's go and connect one of them. That's my 13. And CD is my X. Can we use Pythagorean?
Yes.
Or can we also use our triple? 5 it is. All right. Our next one is a little bit awkward because one information is not given to us. But let's go ahead and highlight. Here I have 2 tangents. And when given 2 tangents, we have to use the full circle. So here's my big arc. And then here's my smaller arc. And if the smaller arc is represented as x, could I write 360 minus x for the larger arc? So 360 minus x. And my angle is on the outside. So do we add or subtract? Subtract. So let's do some work on the side over here. We know angle 72 is equal to the large arc 360 minus x minus a smaller arc x divided by 2. Should we combine like terms? Could you also multiply by 2 at the same time?
Yes.
But to avoid the big number, we can keep it as it is. And then I can divide those 2 components by 2. Okay? But you can multiply by 2 at the beginning. We'll get the same answer. So we have 72 is equal to, half of 360 is how many?
180.
And half of 2 is how many? Just 1. And then we can go ahead and move the x over. and move the 72 over, how many would that give me? 108? But the question is asking us to find what?
ADB.
So arc ADB, so I need to plug the 108 in here. So 360 minus 108 is going to give us 252.